Hello friends, welcome back. So now we'll be doing a few questions on progressions and series. Right? The first question is, find the arithmetic progression where 7th and 13th terms are 34 and 64 respectively. Okay, so this is just a warm-up question. The 7th term, write it as A7, is nothing but A, the first term, plus 6B, 7 minus 1, right? 6B. This is 34. And the 13th term is A plus 12D, this is 64. Right. So now you have two equations and two unknowns. Subtract both of them. You get 6D is equal to 64 minus 34, that is 30, or D is equal to 5. Now put it in any of the equations here. So you get A equal to 34 minus 30, it is equal to 4. Right. So we get our arithmetic progression as Now arithmetic progression is A plus D, A plus 2D, like this. So we have 4, 9, 14, 19, like this. This is our arithmetic progression. Right, you can even write further and see. After 19 we have 24, that is 5th term, 6th term is 29, 7th is 34. What was asked in the question. Similarly, you can see that the 13th term is actually 64. Okay. Now, the sum of 4 integers in AP is 24 and their product is 945. Find the numbers. Now look closely how I write the integers here. Instead of writing them as A plus D, A plus 2D and A plus 3D, I try to innovate here. I write them as A minus 3D, A minus D, A plus D and A plus 3D, right? You can check that they still are in AP, but here the common difference is 2D. It's not D here. Okay, so that's not a big deal. We can just, while writing the integers later on, we will just substitute the correct common difference and we should get the answer. Okay, so let's get started. Now we have two equations here. The first one is for the sum. Now, when I write the sum, it is A minus 3D plus A minus D plus A plus D plus A plus 3D. Right? That is 24. Now, look carefully. Minus 3D plus 3D cancels, plus D minus D cancels. And that is the reason why I wrote it this way. Had there been 3 integers, I would have written this as A minus D, A and A plus D. Because the moment the sum comes, the D factor cancels and you directly get A is equal to 24 by 4, that is 6. Half of our sum is done, right? Now also note that A is not the first term here. A minus 3D is the first term, right? Okay, so now let's write the product. The product is A minus 3D, A minus D, now another reason this formulation helps is, now while multiplying, I can club this and this and I can club this and this, right? This is very simple. Instead of completely expanding everything, I can directly write this as A square minus 9D square, right? And this as A square minus D square. Further expansion will give me, now I know what A is, right? So A is 36. 36 minus 9D square, 36 minus D square equal to 945. Let's expand everything. We get 1296 minus plus 9D power 4 minus 360D square equal to 945. Right? We see that 9 is a common factor, and then bringing 945 to the other side, we get the equation as D power 4 minus 40D square plus 39 equal to 0. Right? Now this is a simple quadratic in D square. Okay, take the quadratic as the quadratic in D square, and you will get the the roots as d square is, this is simple, sum is 40, product is 39, so d square can be 1 or 39, right? Okay. Now, once d is 1 or 39, now d can be both plus or minus, right? There is no restriction on this. It can be both plus or minus 1, plus or minus root 39. Now, once the d is plus or minus root 39, we see that the question says the sum of 4 integers, right? Our a is 6, but the common difference, we should make this like 6 minus 3d, 3 into root 39 or minus root 39, then not keep it as an integer. So we discard this. We just take d equal to plus or minus 1. So taking d equal to 1, we get the AP as, or the integers in the correct order as 6 minus 3, that is 3, 6 minus 1, 5, 6 minus 6 plus 1, 7, 6 plus 3, 9. In the other one, we'll get this as 9, 7, 5, 3. Right? So we get the same numbers. That is the thing with d. D, since it is a common difference, we can always reverse the series and the common difference will become negative. So you should still get the same series. Right? So these are the 4 integers, 3, 5, 7, 9. The sum gives 24, the product gives 945. Right. So the next question is find the sum of n terms of the series a plus b, a square plus 2b, a cube plus 3b, and so on. Now, how do I write this? First, I write this as a plus b, which is the first term, a squared plus 2b, the second term, a cube plus 3b, okay, and so on. Right. Now I write this as you see that the a here, the first part, right, the a square, the first term of every term is actually increasing as in a geometric progression. So I segregate that. Right, this is not infinity, this is still n terms, but I just leave the n term. And similarly, b plus 2b. Now you see the second part is actually increasing as an arithmetic progression, right? So this is actually a pretty simple problem now. It's just the sum of a geometric as well as an arithmetic progression. The first one gives me a into a power. Now there are n terms and the common ratio is also a. That is a into a power n minus 1 by a minus 1. Now this is nothing but n by 2 into b, and the last term is actually nb, right? So simplifying all of this, I get a power n plus 1 minus a by a minus 1 plus n by 2 into n plus 1 into b. This is the sum. Right? So we see that it's actually because it's a pretty simple problem when you segregate both the series and work on them individually. Right? So the first is just a simple geometric progression, the second is a arithmetic progression, add them and you get the answer. Now find the sum of the series 1 plus 2x plus 3x squared plus 4x cubed and so on. Right. Okay. Here what I do is I multiply all these the whole series with x. Okay. So and now I write those terms shifting one place. So the first one, which is now x, I write this under this. Similar to 2x square, 3x cube, all the way like this till tn minus 1 into x plus tn, right? Tn into x2, right? So now subtracting both of them, I get this. S into 1 minus x is 1. Now look at this. Look at this part. 2x minus x gives me x. 3x squared minus 2x squared, x squared. 4x cubed minus 3x cubed, x cube, oh sorry, okay, all the way like this. Now the nth term is actually pretty simple. The Tn here is nothing but Tn minus x times Tn minus 1. You can see that T2 minus T1 was just x. So this should be x power n minus 1. Sorry, it will be minus here. We're subtracting, so there should be a minus here. Tn into x. Right? Now this is simple. This is just a geometric series in x with a common ratio with first term as a minus x times. Now Tn, you can keep Tn as it is. Otherwise, you can just write this. Tn is not that difficult, right? Tn, what is Tn? The first term is, you see that it is 1, then it is 2x, then 3x squared. So it's n times x power n minus 1. Multiplied with x gives me n times x power n. This is n times x power n. Right? So I divide it throughout by 1 minus x here. Okay. X power n by 1 minus x squared minus n times x power n by 1 minus x. Right? This is my sum for this series. Now, if you remember in the formulae and properties, we saw that there was a formula for 1 minus x squared, right? There's actually a formula mentioned for 1 minus x whole power minus 2, right? Or 1 by 1 minus x squared. Now, actually, let's just take the limit of this term as n tends to infinity, and in the domain where x is less than, or the absolute value of x is less than 1, right? So what do we see? We see that the x power n here, this one becomes 0, right? Anything less than 1, when raised till infinity, becomes 0. Similarly, the x power n here. So what we have is nothing but, s is nothing but 1 minus x squared, the whole squared. This is limit as n tends to infinity, and x mod of x less than 1, right? And if you remember, we wrote the formula 1 minus x power minus 2 as 1 plus 2x plus 3x squared plus 4x cubed. So you see how the formula is arrived. It's pretty simple. You actually use the arithmetic or geometric progression and then find the sum. Okay. The next one. If ABC are in harmonic progression, prove that 1 plus a plus 1 plus a 1 by a plus 1 by b minus 1 by c into 1 by b plus 1 by c minus 1 by a is equal to 4 by ac minus 3 by b squared. Okay. How do we? Okay. First of all, we just write down our most important expressions of a harmonic progression, which is nothing but 2 by b is equal to 1 by a plus 1 by c, right? If you know what a harmonic, if you know the first and third term, then you can always set the middle term in terms of them in this way, right? Now I expand the left hand side. The complete expansion gives me 1 by ab plus 1 by ac minus 1 by a squared plus 1 by b squared plus 1 by bc minus 1 by ab minus 1 by bc minus 1 by c squared plus 1 by ac. Right? Okay. So let's cancel let's simplify this. So here 1 by bc and minus 1 by bc cancels. Okay. Now let us regroup all the terms. You have 1 by b squared here. Okay, there is also another term which is cancelled, 1 by ab and minus 1 by ab. You have 1 by b squared here plus 2 by ac minus 1 by a squared minus 1 by c squared. Right? Now look at the last three terms. This can now be written as plus 4 by AC minus 2 by minus 1 by A squared minus 1 by C squared, right? So now these three terms, they are nothing but 1 by A plus 1 by C whole squared multiplied with the minus, right? Take the minus out. This is nothing but 1 by A plus 1 by C whole squared. So we get 1 by B squared plus 4 by AC minus 1 by A plus 1 by C whole squared. But we know that 1 by A plus 1 by C is nothing but 2 by B, right? Is there in the harmonic progression. This is 2 by B whole squared, which gives me 4 by B squared. There is already 1 by B squared there. So we get 4 by AC minus 3 by B squared, which is our right hand side, and hence rule. Right? So you see that we just use the most important property of a harmonic progression and writing it that way, just substituting it that in the given left hand side, we get the right hand side. Okay. Now find the sum to n terms of 3 plus 5 plus 9 plus 17 plus 13. Okay. Now this is an example of a situation where we can use the method of common differences, right? So I write it this way. My SN is okay. Now I shift all of this by one place. Right? This is subtracting both of them. We get Tn is equal to Tn. You get a minus Tn on the right hand side. So I bring it to the left hand side directly. That is equal to 3 plus. The first is, let us look at this. This is 2. The next is 4. Then is 8, 16. So we see that these are of the form 2 power n minus 1. Now be very careful here. This is 2 power n minus 1 and not n. This is the part where the whole the crux of this problem is in this final Tn. You have to be careful while writing whether it is n or n minus 1 or n plus 1, right? So we see that this is actually 2 power n minus 1. Now adding this whole thing up, we actually get this is nothing but 2 power n minus 1 by 2 minus 1, which is just 1. Right. So this is 3 plus 2 power n 2 into 2 power n minus 2, or this is just 2 power n plus 1. Actually, so we see a very simple result for Tn. If you actually look carefully at the terms, the first is 3, right? So this is 2 plus 1. The next is 5, 4 plus 1, which is 2 squared plus 1. Then 9, which is 2 cubed plus 1, right? So we get Tn as 2 power n plus 1. Now we are supposed to use the properties I told earlier. Right? Sigma 2 power n. Now what is sigma 2 power n? Sigma 2 power n, this is obviously from 1 to n. Right? So sigma 2 power n is nothing but the first term is t, and then it's there are n terms, which will be n plus 1 minus 1 by 2 minus 1 plus sigma of 1, which is just n. Right? Okay, sorry, this is not n plus 1, this should be just n. I'm sure you see how this is n. There are n terms here, so this should be the power of n. Right? So 2 to 2 power n minus 1 by 2 minus 1. So it's just 2 power n plus 1 plus n minus 2. So we see that the sum is actually given by a very simple formula, which was arrived at using the properties of sigma of 1, sigma of 1 squared and all those things, and using the method of common differences. Okay. Now find the sum of 1 into 3 into 5 into 7 plus 3 into 5 into 7 into 9. So these dots are just multiplication written as dots. Okay, so it's not 1.3.5 plus 0.7. This is 1 into 3 into 5 into 7. Okay. So look carefully. This is done in a different method. How I do this is, first of all, I can easily write my Tn. Right? My Tn is 2n minus 1, 2n plus 1, 2n plus 3, 2n plus 5. Right? Let us put n equal to 1 and see. 1 into 3 into 5 into 7. Right? So that's the same thing. The second one is also 4 minus 1, that is 3, 5, 7 and 9. Right? So this is the correct form. Okay. Now what I do is, I manipulate this, adding a prefix here of 2n plus 7, which is the next term after this, and minus of 2n minus 3, right, which will come before this, right. So this actually gives me 2n plus 7 minus 2n plus 3. So n cancels and we have only 10. So I divide by 10. Right. So this is how we get our Tn. Now, just the only important part was manipulating it this way. Now I expand this. Okay. So my 2n plus 7 multiplies with all these 4 terms, and I'll take 1 by 10 common first. 2n minus 1, 2n plus 1, 2n plus 3, 2n plus 5, 2n plus 7, minus, because there is a minus here, this is 2n minus 3, 2n minus 1, and write them in the increasing order for just so there is no confusion anywhere. Right. So this is my Tn. Now let us call the first part as n. As Vn. Okay. So let us call this as Vn and this as V of n minus 1. Right? You just take this as n minus. You just take the first one as n, and similarly, obviously, the second one will become n minus 1. Because 2 of n minus 1 minus 1 is 2n minus 3, and similarly, you get all the terms. Okay? Now, what I do is, since I've got this kind of a simple relation, where there is subtraction between two terms, now I add all of them up. Right? So, Sn. Now, if you have any confusion, you better write all of this as r. Right? Tr equal to 2, replace n by r everywhere. So, I'll write it that way, so that there is no confusion here. Now this goes from 1 to n of Tr, which is Vr minus V of r minus 1. Right. Now let us crunch all these numbers, and you see that this is nothing but Vn minus Vn minus 1, Vn minus 1 minus Vn minus 2, all the way till V1 minus V0. All of this, there is a 1 by 10 multiplication factor here, right? Right. So now we see these terms cancel off, right? The only term which doesn't cancel is the most extreme ones, which is 1 by 10 Vn minus V0, right? But what is Vn? Vn is nothing but 2n minus 1 into 2n plus 1 into 2n plus 3 plus 2n plus into 2n plus 5 into 2n plus 7, right? Sorry. 2n plus 5, 2n plus 7. We also get now this, right, by 10. Okay. How do we get this last one? This is because of the first term, 1 into 3 into 5 into 7. Right. Okay. So that concludes this question. Now the next one. Prove that a plus b plus c into ab plus bc plus ca is greater than 9 abc. Okay. So here we use the arithmetic geometric inequalities. So what we do is we first apply this on a plus b plus c. Right? If we apply this on abc and we get this as abc power 1 by 3. Right? Now we apply this on ab, bc and ca. And that gives me ab, bc, ca power 1 by 3, which is nothing but a squared, b squared, c squared power 1 by 3. Right? Now I multiply both sides. Since the same inequality exists between both the equations, I can multiply the corresponding left hand sides and the right hand side. So I get 3 into ab plus by 3 is greater than abc power 1 by 3, a squared, b squared, c squared power 1 by 3. That's just 3. Now this is equal to nothing but, okay, this is 1 by 3 as the power, so you can take that common and you have a cube, b cube, c cube power 1 by 3, which is abc. Right? And I cross multiply the denominator 3, the 9 here, and I get okay. So we see that just applying the AMG inequality, that arithmetic mean is greater than geometric mean, we get this relation. Okay. The next question: if ABC are positive real numbers such that a plus b plus c equal to 18, find the maximum value of a squared, b cube, c power 4. Right. So this is where we will see the application of weighted means, weighted mean inequality. In the previous video, I talked about weighted means. The weighted means also have the same inequality, that the weighted arithmetic mean is greater than weighted geometric mean is greater than weighted harmonic mean. So, what I do is I need a square here, b cube and c power 4. So I will write this as 2 into a by 2 plus 3 into b by 3 plus 4 into c by 4. Why I write this will be clear shortly. Right? So I write it this way. Now you can see that instead of ABC, I am considering a by 2, b by 3 and c by 4, and the weights are 2, 3 and 4. Right? So now let us apply the weighted mean inequality, that is a star is greater than g star. Actually greater than or equal to. So I have 2 into a by 2 plus 3 into b by 2 plus 4 into b by 3, by 2 plus 3 plus 4, that is greater than or equal to a by 2 squared, b by 3 cube, c by 4 the whole raised to 1 by 2 plus 3 plus 4, which is 9. Right. Now let us look at the left hand side. The left hand side is this is nothing but actually the given condition, right? A plus b plus c equal to 18. This is 18. Denominator I have 9. That is greater than or equal to. Now let us simplify the right hand side. The right hand side is a squared b cube c power 4. Right. So this is where this is why we wrote it this way. Now we get the required value, right? A squared B cube 1 super. We got that expression, and now we can find out its maximum value. Now the denominator is 2 squared 3 cube 4 power 4 by 1 pi power 1 by 9. Okay. Just reversing the inequality we get, and raising both of them to the next power, we get a squared b cube c power 4 by 2 squared 3 cube 4 power 4 is less than or equal to 2 power 9. Right? So this is what we get. Now let us simplify this. 2 power 9 into 2 squared into 3 cube into 4 power 4, which is equal to 2 power 9 plus 2, that is 9 plus 2, and 4 can be written as 2 squared, which is, gives me 8 here, 3 cube, which is equal to 2 power 19, sorry, 3 cube, right? So I see that the maximum value of a squared b cube c power 4 is as high as 2 power 19 3 cube. This is the maximum value. Obviously the equality is the maximum one. Okay. Now this question, if a plus b, abc are positive real numbers such that a plus b plus c is equal to 1, prove that a by b plus c plus b by c plus a plus c by a plus b is greater than or equal to 3 by 2. Okay. So now here there is a very important inequality called the nth power arithmetic mean inequality, which states that a1 power m plus a2 power m, a3 power m till an power m by n is greater than or is actually strictly greater than this is greater than or equal to a1 plus a2 plus a3 till an by n power m. So you see that if m is equal to 1, this actually becomes a trivial case, right? And the main thing is m should not lie between 0 and 1. So m here lies between, does not lie between 0 and 1. Okay. Both of them are not included. So you actually cannot, you can see that if you put m equal to 1 here, you get back, okay, that is where you get actually the inequality. That is why you can write this as the open interval, because 1 actually gives us the equality. Okay, so this is called the mth power arithmetic mean inequality. Okay. Now what we do is we carefully choose our a1, a2 and a3, and we again carefully choose our m. Okay. So I do this. I take a1 as a plus b, a2 as b plus c, a3 as c plus a. I take m equal to minus 1. Okay, so m actually can take all possible values, but I take this, so negative numbers are also allowed, and I take this as minus 1. Let us see what the inequality translates to. So I have a plus b inverse, b plus c inverse, c plus a inverse divided by 3 is greater than or equal to a plus b plus c plus c plus a by 3 whole inverse. Right? So we see that this is how cleverly, now the right hand side has only a, b and c, right? A plus b plus c, twice of that. And since the value is known, this becomes just 2 divided by 3 minus 1. Right? So writing them properly now. So this is greater than or equal to, the right hand side is actually 3 by 2 into 3 by 2, that is 9 by 2. Right. But this is not what is asked in the question. The question asks for a by b plus c plus b by c plus a and so on. Right. So what I again do is, again is the condition that 1 is equal to a by a plus b plus c. So I substitute a plus b plus c everywhere. Right. Now I see that for the first one I can take a plus b common. Second one I can take b plus c common, and similarly for the third one I can take a plus c common. That will actually give me just 1. And what now remains is just this much. There was 1 from each term, so that gives me 3. And this is greater than or equal to 9 by 2. Right? So just rearranging the terms as required in the equation and taking the 3 to the other side, I get my property that 1 a by b plus c plus b by c plus a plus c by a plus b is actually greater than or equal to 3 by 2. Right? In these videos we saw some of the most important properties and theorems related to progressions and series, and we also tried our hand at some of the most important and regularly asked questions in all competitive exams. So thank you. Stay tuned for more videos.